Look at these potatoes. Perfectly oval, uniformly brown, utterly boring. Every single one looks identical to the next. Now imagine if I told you that we're eating the most genetically impoverished version of one of humanity's greatest agricultural achievements, and that this monotony nearly caused a catastrophe that killed over 1 million people. The truth is, potatoes were never meant to look like this. The original potato story is one of stunning diversity, ingenious innovation, and a civilization that engineered one of the world's most important foods from a poisonous wild plant in one of Earth's most inhospitable environments. By the end of this video, I'll reveal the shocking discovery that changed everything we thought we knew about when potatoes were first domesticated, a finding that pushed the timeline back thousands of years and was hidden in the most unlikely place. But our story begins 8,000 years ago, in the thin air of the Andes Mountains, where survival meant solving an impossible problem. The Andes Mountains of South America present one of the most challenging agricultural environments on Earth. We're talking about altitudes between 10,000 and 15,000 feet above sea level, so high that the air contains 40% less oxygen than at sea level. Temperatures swing wildly, scorching sun during the day, plummeting below freezing at night. The growing season is brutally short. The soil is thin and rocky. And yet, this is where ancient Andean peoples not only survived, but thrived. Around 8,000 BCE, hunter-gatherers in this region encountered wild potato plants growing naturally in the Andes. These weren't the potatoes we know today. Wild potatoes, Solanum brevical and related species, produced tiny tubers, some no bigger than a marble, and they were loaded with toxic compounds called glycoalkaloids. Eat a wild potato raw, and you'd experience a bitter, burning sensation, followed by nausea, vomiting, and potentially worse. These compounds evolved as the plant's defense against being eaten. So why on earth would ancient peoples bother with such an unpromising food source? The answer is simple: desperation breeds innovation. At these extreme altitudes, traditional crops like maize struggled or failed entirely. The ancient Andeans needed a crop that could handle frost, thin air, poor soil, and intense UV radiation. The humble potato, despite its toxicity and size, had one critical advantage: it could grow where almost nothing else would. But recognizing potential and actually domesticating a poisonous plant are two entirely different challenges. What happened next represents one of humanity's greatest acts of genetic engineering, accomplished without laboratories, without understanding genetics, and without any scientific instruments whatsoever. Domesticating the potato took countless generations of careful observation, selection, and cultivation. The process likely unfolded something like this. Early cultivators noticed that not all wild potato plants were equally toxic. Some had slightly larger tubers. Some were slightly less bitter. These observations became the foundation of artificial selection, though they wouldn't have called it that. Generation after generation, farmers saved tubers from plants with desirable traits: larger size, lower toxicity, better taste, higher yields, different colors. They planted these selected tubers and repeated the process. Over centuries, the genetic makeup of potatoes began to shift. But here's where it gets fascinating. Unlike wheat or rice, which were domesticated from one or two wild ancestors, potatoes have an incredibly complex genetic heritage. The Andean peoples weren't working with just one species. They were cultivating and crossing multiple wild potato species, creating an explosion of diversity. Potatoes can have different numbers of chromosome sets: diploid, 2 sets; triploid, 3 sets; tetraploid, 4 sets; even pentaploid, 5 sets. This chromosomal flexibility allowed for incredible variation and the development of varieties adapted to specific microclimates. The result? By the time of the Inca Empire, Andean farmers had developed over 3,000 distinct potato varieties. Not slight variations, fundamentally different potatoes adapted to specific altitude zones, each with unique flavors, textures, colors, and growing requirements. There were potatoes that could withstand heavy frost, potatoes that grew in sandy soil or clay, bitter potatoes that remained toxic but could be processed for storage, sweet potatoes for immediate consumption, red potatoes, purple potatoes, potatoes with yellow flesh and red skin, potatoes so dark they're almost black. But genetic selection was only half the story. The Andeans also developed remarkable agricultural technologies to maximize potato production in their challenging environment. They built sophisticated terrace systems, Andins, that created microclimates and prevented erosion. These terraces captured heat during the day and released it at night, protecting plants from frost. They incorporated irrigation channels that moved water efficiently across mountainsides. They developed the waru-waru system, raised planting beds surrounded by water-filled canals. The water absorbed heat during the day and released it at night, creating a thermal buffer that could protect crops even when surrounding areas froze solid. These weren't primitive farming methods. They were sophisticated environmental engineering systems that modern agronomists still study for inspiration. Growing potatoes at high altitude was an impressive achievement. But the Andeans solved an even more critical problem: how to preserve potatoes for months or even years in an era before refrigeration. Their solution was brilliant: chuno, the world's first freeze-dried food. The process takes advantage of the Andes' unique climate, freezing nights and intense daytime sun. Here's how it works. Farmers spread freshly harvested potatoes on the ground during the coldest nights of winter. The potatoes freeze solid. The next morning, family members, often barefoot, literally stomp on the frozen potatoes to squeeze out moisture. This process repeats for several days: freeze, stomp, squeeze. Eventually, the potatoes are exposed to intense high-altitude sunlight for several more days. The result is chuno, hard, dehydrated potatoes that look like small, shriveled stones. Chuno can last for years without spoiling. It's lightweight, transportable, and can be rehydrated in soups and stews. This invention transformed Andean civilization. The Inca Empire built massive storehouses, kulkas, that held chuno and other preserved foods. These weren't just for emergencies. They represented economic power, military logistics, and social insurance. With chuno, the Inca could feed armies on long campaigns. They could support workers building roads and temples far from agricultural centers. They could provide relief during droughts and crop failures. In many ways, chuno enabled the Inca Empire's expansion across 2,500 miles of South American territory. Archaeologists have actually found ancient chuno in Inca sites, still identifiable after centuries, a testament to the preservation method's effectiveness. For Andean peoples, potatoes weren't just food. They were woven into the fabric of culture, spirituality, and identity. They worshipped Axamama, the potato goddess, who ensured successful harvests. Religious ceremonies marked planting and harvest times. Offerings were made to mountain spirits called apis, who controlled the weather and crop success. Potatoes even served as a unit of measurement. Time could be measured by how long it took to cook a potato. Small plots of land were measured by the topo, the area needed to grow enough potatoes to feed a family for a year. The cultural importance of potatoes continues today. In Andean communities, traditional festivals still celebrate the potato harvest. Ancient varieties are still grown using traditional methods. The knowledge of thousands of years of potato cultivation is passed down through generations. These communities maintain potato diversity that exists nowhere else on Earth. They're not just farmers. They're living libraries of agricultural knowledge and genetic guardians of irreplaceable crop diversity. How do we actually know potatoes were domesticated 8,000 years ago? Archaeological evidence provides fascinating clues. In 2005, researchers made a breakthrough discovery at Jisquirimoco, a site near Lake Titicaca in Peru. They found fossilized potato starch grains on grinding stones and in dental calculus, essentially ancient plaque on human teeth. These starch grains could be identified as potato based on their distinctive shape and structure. Using radiocarbon dating, the site was dated to approximately 8,000 years ago, pushing back the timeline of potato domestication by thousands of years. Similar findings at other Andean sites confirmed the pattern. Ancient settlements showed increasing evidence of potato cultivation and processing over millennia. Excavations have revealed sophisticated agricultural tools, specialized digging sticks, stone hoes, and processing equipment. The evolution of these tools parallels the evolution of potato cultivation itself. Pottery from later periods depicts potatoes in various forms. Some Moche and Nazca ceramics from around 200 to 700 CE actually shaped vessels like potatoes or painted potato plants on their surfaces. Perhaps most remarkably, the archaeological record shows that by 2,000 years ago, the range of potato diversity already approached what the Spanish would encounter in the 1500s, proof that Andean peoples had been refining and expanding potato varieties for millennia. Remember that shocking discovery I promised? Here it is. The evidence that pushed potato domestication back to 8,000 years ago was literally hiding in people's teeth. Those fossilized starch grains in ancient dental calculus survived millennia, waiting to reveal their secret. When researchers first looked at grinding stones, they found potato starch. But the clincher came from dental calculus, because it proved people weren't just processing potatoes, they were eating them regularly enough that starch became trapped in their dental plaque and fossilized. This discovery revolutionized our understanding of Andean agricultural history, proving that potato domestication was contemporary with wheat domestication in the Middle East and rice domestication in Asia. The potato's journey from toxic wild plant to global staple represents one of humanity's greatest collaborative achievements. Thousands of generations of observation, selection, and cultivation in one of Earth's most challenging environments. Today, organizations work to preserve Andean potato diversity. The International Potato Center in Lima maintains over 4,000 varieties. Indigenous communities continue growing traditional varieties using ancient methods. So the next time you see those uniform brown potatoes in the supermarket, remember, you're looking at a shadow of what potatoes can be. The real potato story, written over 8,000 years in the high Andes, is far more colorful, far more diverse, and far more remarkable than most people ever imagine. From toxic wild plant to global staple, from the thin air of the Andes to every continent on Earth, the potato's journey is ultimately a story about human ingenuity, perseverance, and the remarkable things we can achieve when we work with nature across generations.